Hello everyone, Keith Park here with Printer World. I got some excitingly cool things to talk to you about today. One of them, of course, is going to be an update on my Halloween creation. But first, I have what I consider to be a real treat for you today. I'm going to go and talk about photogrammetry, and I'm going to go and talk about 3D scanners. And I'm going to talk about how you can go and take your outside world around you, put it inside of here, and then you can go and be able to do anything you like with it. That is cool stuff. Alright, so first off, I want to go talk about the two main types of scanners that we have available here. Right? One of them right here is a conventional photogrammetry scanner. Now what it is doing is it takes pictures both from below and above it, and it goes and rotates the object right there in 360 degrees in order to take a whole bunch of pictures, right? It then uses a program to go and process all those different angles. It factors in ideas of light and shadows and things like that. It produces a pretty accurate result in the end. I've seen, for instance, a compressor wheel that has been made. They show it as an example on the site that they wound up presenting the Open Scan Mini on. That's what this is called, by the way. That's a really cool thing about it. It's open source. The guy has made it available for anyone to come along and use it. You do have to buy parts, not necessarily from him. You can get them from a variety of different places. But the point is you can make a scanner that can let you be able to scan something that is 9 centimeters or smaller into your computer that you can then do just about anything you like with, including 3D print it, right? Now you're going to go and say, okay, yeah, but like, who has just only 9 centimeter items to go and scan in? Do we want to scan it in larger things like people, parts of cars, things like that? Well, sure. Now that's where you're getting into something like this Revel Point Pop right here. Now, I really like this little unit. I got to tell you at first, it took a bit of time to go and warm to, because it does take a little bit of learning how to go and use it. It's a little picky, but what it does is it uses lasers to go and determine the surface all the way around it as you're going and moving around it, either with a turntable or carrying it yourself, to go and scan the object into the computer. Now, it can do this with a person's face. You can do all kinds of really cool things with it. Let's just say you want to go and, go take your car dash, and you want to go and add into it a new unit. Well, you've got to measure out the shape of the car dash so that when you go and actually print it, the faceplate will fit level with what's in there. And you could do a lot of this with physical measuring, or you could just scan it in, put it into your computer, and oh look, now you have a place you can experiment putting all kinds of different things in, and go and imagine for yourself how it would look. Now, does that mean you can put it in an entire car? Well, now we're going to get to some of the limitations of these different things. Now, this particular scanner right here, it requires that it is plugged into a phone or into a laptop computer, and its size of what it can take is directly relative to the amount of RAM that it has. Now, I'm sure you can imagine what kind of problem that is when you're dealing with cell phones, which don't typically have as much memory as a PC might. That is changing in some instances, but nonetheless it does limit the overall size. So you might be able to take a bumper and scan it in, and then you can scan in a quarter panel or a larger section or a whole door, and then add in all the parts together. I suspect you probably could get a larger item on in. It's just, again, the problem is making sure you have enough memory to do it. I've seen some cool things too, like people scanning in statues at parks and things like that, and it's got me thinking that I might want to try something like that myself. So far, I have to admit, I have not been very ambitious in my scanning. One of the things that I scanned in was the mount for the sun visor for my wife's car. I wanted to scan it in so I could 3D print it and replace it because it had cracked and become broken. So that's kind of my point. That's what we use 3D printers for. It's not just rapid prototyping or coming up with ideas in our heads. Sometimes what it is that we are coming about to just go and say, hey, I've got something that I really like and I want to fix it and I don't want to spend money on the part. Oh, well, I guess I'll go make it, right? Well, if you don't have a pattern, you either are going to manually create it yourself, or you could save yourself a whole bunch of time and just scan it on in. Now, you're probably wondering, why did I leave the light on here and put the glue on up there so you can see? I wanted you to see that it actually gets a really, really good picture in place here. However, there's a lot of glare that's on this. I haven't finished one part of this 3D scanner, and I'm actually going to come on to talking about that when I wind up talking about the other fun thing in just a minute. But it's not quite done. The part that's not done is I have to go and put in a polarization filter so I don't have as much glare on there. Now, I'm going to hold this on up here. I'm really hoping that everyone's going to be able to see what this does, but when I hold it like this, when I change these two pieces of polarized film and I change their angle, they start to get darker the more I change it so that it changes not parallel anymore. When I go back parallel, it goes through again. Using this, I can be able to go and filter out the excess light so we don't wind up with as much glare coming back from it. Well, you know what? That's at least the theory. It was hard to get this polarized film. I couldn't believe it. When I wanted to go and get it off of Amazon, which seemed to be the only place I could find it, it had to come from Israel. Well, interesting, nonetheless, but it wasn't terribly expensive, so it's not a huge roadblock by any stretch of the imagination. And actually, you can do the scanning without it. You can get some pretty clean results. You do get better results using a polarized film by everything I have read from everybody who has discussed this on the forums. Now, I brought on up the whole thing of how this isn't finished. And that's what I mean in terms of that film. I had to wait to get the film. Often when we are doing these 3D printing projects, which, you know, this is how you learn things, is by doing stuff, we run into a roadblock along the way and we go like, I hadn't really thought about what I was going to do when I got to this point. What do I do then? I was able to build the whole scanner. This is all 3D printed off of one of my printers, except the electronics, of course, which I soldered and put together myself. But, you know, one of the roadblocks I ran into after I put it together was, what the heck do I do with it now that it's put together? Why? You know, for all my IT background and experience, I don't have a lot of experience with Linux, to be honest with you, right? And, you know, I've got to tell you that I wasn't used to the idea of going in there and setting it up to go and work through Linux and to go and capture the photos to be able to go and download them to somewhere else. It actually didn't turn out to be as hard as I thought in the end. So I'll probably do a tutorial on it at some point to go and discuss the finer points of how I actually built this and got around some of the complications associated with setting it up, because, you know, where I ran into a struggle, you might also, and maybe that's helpful for you. So I brought that on up because often we will run into that roadblock. That is where I'm now going to bring on up my wonderful creation that I've been putting together so far. Isn't this awesome? I think it's pretty cool anyway. I love the fact that in addition to being able to go and open its mouth with the motors, it's got quote-unquote these lip teeth here so that its lips can be able to go and move up and down, etc. We've got all the other motions that are associated with it there, including, hey, I've got cheek motors too. And the tongue also moves. So then I'm sure you're going to say, well, hey, with all the cool motion you saw the other day, with the, you know, the eyeballs moving all over the place, etc. Hey, why is the mouth going jump, 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 jump? Well, because the part of the equation that I should have considered is that there's a lot moving there, and especially if I want it to go and talk, it needs program behind it, you know, to actually tell it how does it move. So there are some different paths and avenues that I've been thinking about. I'm going to see whether or not that they're viable or not before I necessarily share them, but I mean, I still think it's an awesomely fun build. I can manually maneuver the servo motors, both with my hands and also with a test servo box I'm building shortly. You'll see that in another video, and you'll get a chance to see the mouth moving then under the power. But I do realize if I want to make this something really cool by Halloween, I've got a lot of work to do to get it done. The main reason why? Well, my first part of it, the eyes, it used a total of 6 servo motors. 6 of these smaller ones. This down here uses 2 much bigger servo motors, and it uses 7 of these smaller motors. So that's getting it to be quite a few different control points. One of these control point boards allows for 16 connections. So I can still technically make it work with what's here off of the one control board, and I can code it to go and do that. That will certainly be the end of what I can go and do with it with this one board. I'm going to see what else I can do with it beyond that. Now, a couple of other points I'd like to go and address before I go and start to wrap this on up for the day. I think it is really, really important to go and look at your world all the time and go and ask yourself, what is it that is missing here? What can I make? What is it that someone else might need from me? You know, there's a great story that was told to me in an MIT course that I wound up taking. It's about Peloton bikes. You know, this Peloton bike craze we've seen recently. Okay, so someone along the way went and said, you know, what's missing on these Peloton bikes? There is no phone holder. There's no phone holder on the Peloton bikes. Okay, so if there's no phone holder on the Peloton bikes, and there's all these people who are using it in an online format, they need some place to hold their phone, someone got to thinking, man, you know what? What if I made this cell phone holder for a Peloton bike? They 3D printed it. My understanding is that they sold $200,000 worth in the first month. Because they looked at what was a need that had to be met. Could they somehow do it? Well, why couldn't you go and scan something in and use a program like Tinkercad or Blender or other programs like that to go and create something like that also, and then 3D print it, and then have people test it. Maybe they love it so much, you make a whole bunch more. Right? That's what I mean when I say print your world. And I've got so many more of these things to talk about and to show you, and ideas on how to use this equipment to go and create those things. And I definitely look forward to going and showing you something else kind of cool, because I'm going to be putting these kinds of eyeballs right here like that. You see that? Oh, that's going to be inside of my friend right here. Now, the next thing that I want to go and try and do with him, I'm going to try and come up with some kind of face covering that I want to see if I can 3D print it, like out of TPU or something like that. I don't know how successful that's going to be yet. I was originally going to do a mask or something else to that effect, but I think I might even challenge myself a little bit more, because that's the fun with 3D printing also, is to always continuously challenge yourself with new things and to constantly read how do other people do it. Watch their videos. Ask them questions. In fact, I invite any of you to ask me questions or give me ideas in the comments below. I really appreciate it. If you haven't subscribed yet and you thought that any of this content was kind of cool and you'd like to see more, please subscribe. And please also like. I look forward to going and seeing you more. And again, I will be getting this video editing down in the future. Have a great day, everyone.